Hello, everybody, and thank you for joining us today for Vertica Unified 2021. Today's breakout session is entitled Vertica in Eon Mode, Deploying in the Clouds and Beyond. I'm Jeff Healy, I lead marketing at Vertica. I'll be your host for this breakout session. Joining me today are Shruti Anamula and Christopher Daly from the Vertica Customer Success team. Before we begin, I encourage you to submit questions during the virtual session. You don't have to wait, just enter your questions into the Q&A box on the right-hand side of the screen. There will be a Q&A session at the end of the presentation. We'll answer as many questions as possible during that time. Any questions we don't address, we'll do our best to answer offline. Alternatively, visit the Virtual Developer Lounge to ask additional questions and continue the conversation with our engineers and product experts after the session. And yes, this virtual session is being recorded. Will be available to view on demand this week. We'll send you a notification as soon as it's ready. Please stick around to get the code to get points, participate in our Analyze to Win competition, and win prizes. Now let's get started. Over to you, Shruti.
Hi everyone, my name is Shruti Anumula. In today's presentation, we'll be talking about Eon Mode architecture and deploying Vertica on AWS, GCP, and Azure. We will be also reviewing the deployment of the Vertica Eon Mode on-premises on Pure Storage, Minio, Scality, and HDFS. Before going into Eon architecture, let's discuss advantages of cloud computing and whether it is worth moving your applications to cloud. Firstly, you can spin up your instances or virtual machines easily within few seconds without having a second thought about the hardware limitations, which is a common issue for hosting applications on premises. Based on your growing needs of your business, you can scale up the instances quickly or scale down when there is low demand, which can help in cutting down the operational costs. With pay as you go model, moving to cloud will definitely help in lowering the IT costs. Cloud vendors offer multiple disaster recovery strategies one can choose based on the priority of the application in their business. For example, AWS offers Cloud Endure, a disaster recovery solution which continuously replicates the applications into low-cost staging area. Last but not the least, cloud providers offer more security to your data by providing more granular permissions and restrictive access to data and encryption and so on. Without any further delay, let's get started with Eon mode. What is Eon mode? Eon mode separates the computational processes from the storage layer of your database. When running Vertica on Eon mode, you can store data on cloud or on premises. Storing data in cloud is more resilient and less prone to storage failures. Based on your growing needs of your business, you can scale your Eon Vertica cluster quickly. One can create subclusters and group the nodes based on the workload. Performance of the query will depend on whether the data is present in the depot or S3 communal storage. Since compute and storage are decoupled, one can scale each of them independently. Let's get a deep dive into Eon mode architecture. As mentioned earlier, data gets stored in communal storage. As you can see in the picture, data in the S3 bucket is divided into four segments. In Vertica terminology, each segment is called a shard. We have 8 nodes. Each node is subscribing to 2 shards. For example, consider the red shard. It has been subscribed by 4 nodes, that is, 2 nodes in the ETL subcluster and 2 nodes in the query subcluster. If one of the nodes in the ETL subcluster, which got subscribed to red shard, goes down, other node will serve any query pertaining to red shard, ensuring high availability. One of the most striking features of Eon mode is subclusters. Users can divide the nodes in groups called subclusters based on their computational needs. For example, ETL queries require more resources. So, a database administrator can create an ETL subcluster with many nodes. This will not only help with the resource issues, but also helps in isolating the workload. In Vertica, there are two types of subclusters, primary and secondary. For Vertica database to be up and running, more than 50% of the nodes in the primary subcluster should be always up. Secondary subclusters are generally designed for dynamic scaling. You add and remove, or start and stop these subclusters based on your analytical needs. They are optimized for running queries rather than DDL or data loading workload operations. In Eon mode, Vertica has to fetch the data from communal storage, and it can be a bit slow compared to accessing the data from the local disk. In order to improve the speed, Vertica maintains a local disk cache of the data called depot. Whenever you execute a query, Vertica initially checks whether the data it needs is in the depot. If it is, then it finishes the query using the local copy of the data. If the data is not in the depot, the node fetches the data from communal storage and saves a copy in the depot. Users can control, as in from where to fetch the data, by configuring the parameter use depot for reads, which is by default set to 1. So depot is checked first. Let's say you want to query directly the communal storage. You can set use depot for reads parameter to 0. Vertica also uses depot for load or ETL operations, catching the newly loaded data in the depot before uploading it to the communal storage. Use depot for writes is the parameter which decides as in where to write the data. When set to 0, it bypasses the depot and writes to communal storage. When set to 1, it will write to the depot and then upload the files to communal storage. All these parameters can be set either at session level or database level. When you add a new node or restart a down node, their corresponding depots are empty or will have stale data. When depot warming is enabled, a node that is undergoing startup preemptively loads its depot with frequently queried and pinned data. When the node completes the startup and begins to execute the queries, its depot already contains much of the data it needs to process those queries. This reduces the need to fetch the data from the communal storage and expedites the query performance accordingly. Vertica evicts the data from the depot as needed to provide room for new data. It uses least recently used algorithm when evicting files from the depot. Least recently used unpinned object is evicted for any new object pinned or unpinned. Next, least recently used pinned object is evicted for a new pinned object. Now comes the question, what is pinning? Let's say you plan to run some crucial queries many times in a day and you don't want that data to be evicted from the depot. To achieve this goal, you can use depot pinning. One can pin important tables to the depot at subcluster level or database level. Such tables are called pin tables. Users can pin table or partition or a projection to the depot as shown in the picture. Data for these pinned objects is evicted only to make space for more pinned objects. So far, we have seen two processes by which the data files land in the depot. One process is via load process during ETL, and other is when a user issues a select query, and if the file is not present in the depot, it will be downloaded from communal storage. The third process via which the files land in the depot is called peer-to-peer fill. During a load, generally the data is loaded only on the participating nodes, and each participating node loads the data only for the shard that it is serving. But for a different session, you might get a different set of participating nodes. To make sure that the depot is warm for other sessions as well, you can optionally have these participating nodes send the data files to non-participating nodes. In this picture, you can see we had 4 participating nodes, one for each shard. During peer-to-peer shipping, each of these nodes will transfer the files to another participating node and then to one or more non-participating nodes so that their depot has hot data as well. This process is off by default, but again, depending on your use case, you can turn it on at subcluster level or database level and have all the subscribers get the latest data in their depots. Now let's take a look at backup and restore in Eon mode. It is same as enterprise mode except that we allow backups to only cloud storage locations in Eon mode. Currently, we support backups to S3 and GCS. Backups to Azure and HDFS is supported starting Vertica 11. However, for the object restore to work in Eon mode, you should have same shard subscriptions. If the shard subscriptions have changed, you cannot do object restore but can do a full restore. When do shard subscriptions change? Yes, they change only when you add or remove nodes from the cluster. Let's say you don't need your database anymore, but you want to keep it. You can just shut it down, thereby hibernating it. Your data will be still present in S3 bucket. When you need access to your database again, simply provision a Vertica cluster and revive your database. Once revived, you are ready to start accessing your database again. Now let's take a look at Vertica on AWS. AWS is the first cloud environment that started supporting Eon mode as well as enterprise mode. We offer various deployment options for deploying Vertica on AWS. One can spin up a cluster on AWS within few minutes. Easiest way to spin up a Vertica cluster on AWS is via CloudFormation templates offered by Vertica through AWS Marketplace. Vertica offers two types of CFTs in Marketplace, namely Vertica by the hour and Vertica bring your own license with Amazon Linux or Red Hat as the supported operating system. Let's say you plan to install Vertica manually using existing deployed AWS resources. Vertica provides an AMI that you can install on AWS resources. However, users need to choose the right instance types, disk types, configure the network, security, and so on. Let's review each of them in detail. AWS offers numerous types of instance types, each optimized for a purpose. One need to choose a right instance type based on the requirements of your application. Vertica recommends to choose the instance types that support ephemeral instance storage or EBS volumes. However, it is not mandatory to use the instances with EBS for Eon mode because the data is stored in the communal storage. But let's say if you have an option to use EBS based instances for Eon mode, definitely try to use them because it will help in reviving the database faster since depot is preserved on EBS. For Vertica in enterprise mode, it is best to use the instances with EBS since the data is stored on the local disk. Herein we listed a few recommended instance types for Vertica in Eon mode and enterprise mode. Storage optimized instances are most recommended for Eon mode because they provide high IOPS at a low cost. For example, i3-4x large is most economical and can be used for primary subcluster. For Vertica on enterprise mode, we recommend using R4 instances because they are optimized for memory intensive applications and support enhanced networking. Let's take a look at networking aspect that you need to consider. Vertica recommends configuring the gateway S3 endpoint for your VPC. As you are aware, a gateway endpoint is a target for a route in a route table to connect to VPC resources to S3. In this picture, you can see that the instances in subnet 2 can access Amazon S3 through the gateway endpoint. This is very useful for Vertica in Eon mode because it allows egress traffic only to S3 service, which makes it more secure and it's free of cost. Vertica recommends creating the placement groups because it groups EC2 instances close together inside an availability zone and provides low network latency or high network throughput, or sometimes it provides both. Vertica recommends to choose instance types that support enhanced networking because it uses single root IO virtualization to provide high network performance capabilities. Enhanced networking generally provides higher bandwidth, higher packet per second performance, and consistently lower inter instance latencies, and again, it's free of cost. Users must set the control mode as point to point because clouds doesn't support broadcast protocol for spread. Vertica recommends using instance profiles as they are more secure and easier to maintain. If you can, please use the CFTs provided by Vertica in the marketplace because we try to spin up a Vertica cluster quickly with minimal configuration as listed here. Now let's take a look at Vertica Eon on HDFS. It operates the same way as Vertica on cloud or on premises. However, HDFS is used as communal storage. HDFS is a distributed file system which generally provides high durability at a low cost. Vertica has been supporting HDFS as a storage location for many years, and you can also access HDFS data in place using external tables. Vertica can be used with Hadoop distributions from major vendors, namely Hortonworks, Cloudera. To use HDFS as a communal storage for an Eon mode database, one must configure their Hadoop cluster with WebHDFS. If HDFS is configured with high availability name node support, then we will be using your name service ID as the authority in the WebHDFS URIs. Let's say a user tries to load the data into Vertica using HDFS as a communal storage. We are first going to connect to HDFS name node. Name node returns the URI for the data node, and we upload the data in chunks to HDFS data node, which is returned by name node. If the name node doesn't respond, we keep retrying, and upon encountering the configured timeout, query will eventually fail. Let's review some of the common questions raised when deploying Eon cluster using HDFS as communal storage. As mentioned earlier, the data is uploaded in chunks to communal storage. So the most common question which arises is there a way to control the chunk size? Yes, there is a way, and one can modify the block size in HDFS and change the Hadoop FS block size bytes parameter in Vertica accordingly. Another commonly raised question is where does the data get stored when the initial query fails? It is stored in the memory buffer, and WebHDFS upload buffer size KB is the parameter which controls the buffer size. Last but not the least, fault tolerance is governed by dfs.replication parameter of HDFS with default value being 3. Thank you, everyone. With that, now I would like to pass over to my colleague, Chris.
Thanks, Shruti, and hello, everyone. As Shruti talked about earlier, Eon Mode was really designed around the idea of taking advantage of cloud resources to expand Vertica's scaling while reducing the overall cost of running Vertica in the cloud. However, after the release of Eon Mode on AWS, a really interesting thing happened. Companies such as yourselves started adopting object storage technology, and not just for Vertica, but for many things. And in fact, it became so popular that many companies started exploring the idea of bringing S3 compatible storage back into their physical data centers to support object storage in either a hybrid cloud or a complete on-premise solution. And this has become such a popular idea that many storage companies are now supporting the S3 API on many of their physical storage solutions. So what's the next step for Eon Mode then? Well, on-premise, of course. First Devise is an interesting science project between one of our customers and the development team, Eon on-premise has been gaining serious traction over the last few releases of Vertica. So much so that we were getting inundated with requests to support the solutions from many different storage vendors. In fact, the interest was so great, we had to move quickly to mobilize our partner engineering team to help validate solutions from our hardware partners. So who are these partners? On this slide, you can see all the current vendors that we have worked with our partner engineering team to validate their solutions for running Eon Mode on-premise. And while I can't talk about the vendors currently in process or the ones that have already lined up to start it, there are many. The point is that the solutions for Eon Mode on-premise are growing at a fast rate as customers are starting to understand the value of Eon Mode when running outside of the cloud environment. Now, how do you validate a back-end object store for Vertica? Eon Mode was originally written to support the S3 APIs as created by Amazon. And when talking to storage vendors about their particular S3 compatible solutions, one thing that we hear over and over again is we're 100% S3 API compliant. However, in some cases, this statement is a little bit misleading because what's missing is that while the API calls that they support are 100% compliant, they don't necessarily support 100% of all the S3 API calls. It quickly became obvious that what we needed to do was devise a validation process to ensure a vendor's S3 compatible product not only worked correctly with Vertica, but also to understand the ins and outs of the sizing and scaling and the limitations of the products. Let me take a minute to let that sink in with you because this is a major point for deploying Eon Mode on-premise. In AWS, S3 has very few limits. You can grow your bucket without having to concern yourself about how it's being supported on the back end. You can increase the traffic to your bucket without having to concern yourself with overwhelming the network infrastructure. All of this is handled by AWS, and it's all done seamlessly in the background. But when you move this on-premise, guess who's responsible for it now? In order to be successful on-premise, the back-end communal storage needs to be able to scale effectively, both from a size and a performance standpoint. And while the storage array will do the heavy lifting, part of that performance is going to be the networking segments that connect your Vertica nodes to the storage array. This is why we have a validation process for on-premise S3 storage solutions, because before you deploy something, we'd like to make sure it'll actually work. We use several different tools, including a set of tests that use a real Vertica cluster that's designed to push the communal storage to its limits. Storage partners must complete these tests successfully before we'll engage with any sales motion for an Eon on-premise deployment with their solution. In fact, we even ask our vendors who have recently passed through the validation to move forward in the first few sales with us hand in hand to make sure the customers are getting the best possible experience. What do you need to keep in mind when you're deploying Eon Mode on-premise? Well, like I just said, when you move on-premise with Eon Mode, you are now responsible for all the aspects of the performance and scalability of not just the cluster nodes, but the back-end communal storage and all the networking throughput required for the cluster nodes to talk to the storage array. Network performance is going to be a crucial aspect of this. You'll want to isolate the network pathways between the clusters and the storage array as much as possible and provide the fastest and widest links you can. Yes, Eon Mode relies on a local depot for the majority of the work, but the final mile between the cluster nodes and the communal storage is going to be one of the most obvious bottlenecks in any Eon Mode deployment. Also, do your homework on the storage array you plan to use. Understand how it will scale from both a scale-up and a scale-out perspective. Don't plan for the workload you have today, plan for the workload you're going to have in 12 or 18 or 18 months' time or 24 months' time, as this will alleviate issues in the short term, allowing you to focus on your day-to-day business. And finally, work directly with your storage vendor to help build up and not only the hardware recommendation, but your long-term plans for growth. Each of the storage vendors that have passed through the validation process have different methodologies for scaling. Understanding those today will make it easier to implement them when the time comes. Now, let's switch gears and move back to the cloud. While AWS gets the majority of recognition from Vertica in the cloud perspective, and rightfully so given our long history with them, Google Cloud Platform has been a very popular platform for running Vertica in Eon Mode. GCP is actually the second cloud to see Vertica Eon Mode in general availability, back with the Vertica 10 release. What is most interesting about that is that shortly after the release of Eon Mode in GCP, we also started offering a by-the-hour licensing option, allowing customers to quickly spin up an Eon Mode cluster with no licensing limitation, only paying for the actual usage time on the cluster. This licensing model followed a similar one already being offered in the AWS space. And while we've done a lot of work to accommodate the solutions coming out of Marketplace on GCP, we also recognize the simple fact that for a lot of you, building your cluster manually is the only option to meet the company or IT specific requirements. So with that in mind, let's talk about the things you need to understand in GCP to get that done. Does this slide look familiar? Yeah, it's a duplicate slide from the AWS section, but it's merely just an acknowledgement of all the things you need to consider when running Vertica in the cloud. In Vertica, the choice of the operational mode will dictate some of the choices you'll need to make in the infrastructure, particularly around storage. And just like the on-prem solutions, you'll need to understand disk and network performance and capacities to get the most out of your cluster. And one of the most attractive things about GCP is the pricing, but that tends to run a little bit less than the others, but it translates into less choices and options. If nothing else, the thing I want you to take away from this slide is that VMs in GCP are running on top of hardware that has hyper-threading enabled, and that a vCPU doesn't equate to a core, but rather a processing thread. This becomes particularly important if you're moving from an on-prem environment into the cloud, because a physical Vertica node with 32 cores is not the same as a VM with 32 vCPUs. In fact, with 32 vCPUs, you're really only getting 16 cores. GCP offers a handful of VM types categorized by letter. But for us, most of these don't really make great choices for Vertica nodes. The N series, however, does offer a good core-to-memory ratio, especially when you're looking at the high-mem variants. Also, keep in mind, performance of I/O, such as network and disk, are partially dependent on VM size. So customers in the GCP space should be focusing on 32 vCPU VMs and above for their Vertica nodes. Disk options in GCP can be broken down into two basic types: persistent disks and local disks, which are ephemeral. Persistent disks come in two forms, standard and SSD. For Vertica and Eon mode, we recommend that customers use persistent SSDs for the catalog, while either local SSDs or persistent SSDs are acceptable for depot and the temp space. A couple of things to think about here. Persistent disks are provisioned as a single device with a settable size. Local disks are provisioned as multiple devices with a fixed size, requiring the use of software rating to create a single storage device. So while local SSDs provide much more throughput, you're using CPU resources to keep and maintain the RAID set. Also, VMs that are created with local SSDs can't be stopped and restarted like normal VMs. Your only choice is to either leave it running or decommission the VM, which is basically destroying it. So when it's time to use that particular cluster or subcluster again, you're reviving it, not simply restarting it. And this can take a much longer time. Persistent disks offer redundancy either within the zone they exist or within the region. If you select regional, the disk is replicated across multiple zones within the region for redundancy. But this has an effect on the performance of the VM. This is why we recommend that you choose zonal redundancy when you're using persistent disks. Also remember, in the cloud space, all I/O is network I/O, as persistent disks are block storage devices attached to the network. This means that disk actions can and will slow down network traffic. And finally, storage bucket access in GCP is based on GCP's interoperability mode, which basically just means that it's compliant with S3. In interoperability mode, access to the bucket is granted by a key pair that GCP refers to as the HMAC keys. HMAC keys can be generated for individual users or for service accounts. We recommend that customers use the service account to ensure that the keys are not tied to a single employee. Lastly, networking, some things to consider in your Vertica cluster. Pick a region for deployment that's physically close to you. Even if you're connecting to GCP network via a corporate LAN as opposed to the internet, the further the packets have to travel, the longer it's going to take. Also, GCP, like most of the clouds, doesn't support UDP broadcast traffic in their virtual networking, so you're going to have to use the point-to-point flag for spread when you're configuring your cluster. And since the network cap on VMs is set at 32 gigabits per second per VM, maximize your network egress throughput and don't use VMs that are smaller than 16 vCPUs for your Vertica nodes. Last, but by far not the least, there's the Microsoft Azure environment. Offering a much different experience over its rivals, the Azure environment has been growing steadily for some time now. And Vertica has been available in Azure in an enterprise mode for several years. But in Vertica 10.1.1, we released native access to the Azure storage accounts using the AZB source. And now I'm extremely happy to report that with the release of Vertica 11, Eon mode will be generally available in Azure. In fact, in the coming days, you'll see a new Vertica solution in the Azure Marketplace that will allow you to deploy and manage an Eon mode cluster using Vertica Management Console. This is the same methodology we use in GCP and AWS. Furthermore, with the release of Vertica 11, we're moving to a custom-built disk image for both the Vertica solutions and Marketplace. This custom disk image will allow us to offer older versions of Vertica for deployment from the MC moving forward, instead of the current latest version only from Marketplace. And while the MC can make the images point-and-click deployable, customers that use custom automation will be able to directly deploy the Vertica image via ARM templates by simply referencing the plan and offer for the new disk image. I just mentioned that the native access for the Azure Blob storage is currently available, and in this slide I'm showing you the format for usage. While this is similar to the S3 or the GS format for accessing object storage, you'll notice that in Azure, we also need to reference the storage account, not just the container, or bucket as we call it in S3. This is because of a fundamental difference between object storage in Azure as opposed to the other clouds. In AWS and GCP, object storage is a service where you can create buckets for holding your files. In Azure, storage accounts are resources that get deployed alongside your other infrastructure as a service resources. You can have multiple storage accounts, and each storage account can have multiple containers. This basically means that we have to identify which storage account we're accessing along with the container and the path where the data resides. Access to the storage account is granted in two possible ways. You can use the traditional method of providing keys for access to the container, or you can use what Azure calls managed identities. A managed identity is an identity resource that's associated with a different resource like a virtual machine and granted a specific access role and then a scope for that role. For example, you can create a managed identity, give it the storage blob contributor role, scope the role to a specific storage account, and then assign the managed identity to a VM that will access the storage account. This is exactly what we do in the Eon mode solution from the marketplace. The downside to managed identities is that unless you're deploying them from marketplace, the individual setting the role assignment needs to be either the administrator or have owner access to the Azure subscription. This can prove difficult in the case of larger organizations that use Azure and maintain a tight level of subscription level security. In those cases, you can see that feeding the storage access keys into the Vertica via an alter session command is straightforward and an easy approach. So here's the slide again, and in Azure, like the other clouds, there are a lot of similarities for running Vertica. Now that we're supporting Eon mode in Azure, things like node choice become a little different than they have been in the past. You're still going to need to get your local disk performance right, but now there are more options. The other major key is making sure that you're getting appropriate network speeds for your cluster. Overall, Azure is a great platform for Vertica and with the performance and pricing on par with AWS, but keep in mind that Azure uses Hyper-V as its hypervisor, and newer versions of the Linux operating systems like RHEL and CentOS tend to run better than the older ones in this environment. So first things first here, just like GCP, in Azure, VMs are hosted on hardware that is hyper-threading enabled. And because of the way Hyper-V handles this, it actually exposes that directly to the VMs. If you look at the CPU information in the VMs, you'll see how it groups the vCPUs by core and thread. And this will also show up when you run tools like VIO-perf, and as they will detect the hyper-threading and then report the real number of cores being supported by the VM. Azure offers a lot of different VM types, and it's adding new ones all the time. But for us, we see 3 VM types that make the most sense for Vertica. For customers that are looking to run production workloads in Azure, the ES-V4 and LS-V2 series are the 2 main recommendations. While they differ slightly in CPU to memory ratios, and I/O throughput, the LS-V2 series offers advantages in Eon mode. As the LS-V series VMs come with locally attached NVMe drives, which are very, very fast and can be used for depot. These drives are ephemeral, which means when you turn it off, you're going to lose the data that exists there, so only use that for depot. The ES series has in its history offered ephemeral storage, most recently in the V3 options, but for V4 they've done away with that, meaning that you'll need to add additional block storage to support the depot. If you're just deploying a sandbox environment, the DSV4 series is a very suitable choice to reduce overall cloud expenditures, as these nodes are less expensive, but they also have less memory and less I/O capacity. VM block storage in Azure is provided by a grouping of 4 different types of disks, all offering different levels of performance. Introduced most recently, the Ultra Disk is the highest performing option for disk types for VMs in Azure. It was designed for database workloads where high throughput and low latency were very desirable. However, the Ultra Disk is not available in all regions yet, and it's still quite expensive. The premium SSD option, which has been around for a while, is widely available and can offer nice performance in higher capacities with a much better price point than the UltraDisk option. Remember, just like other cloud providers, the I/O throughput you get on VMs is dictated not only by the size of the disk, but also by the size and type of the VM. A good rule of thumb in Azure, VM types with an S are optimized to have a better throughput rates, and larger VMs mean more I/O throughput. Disks come in multiple sizes, and each size offers different levels of maximum performance. Your options to maximize your I/O are either to start with a single large disk or multiple smaller ones striped together using software rating technology like MD-ADM. In testing, we have found that multiple disks in a RAID 0 array outperform the larger single disks, but the trade-off is that you're using CPU cycles on the VM to maintain that RAID set. One nice thing about all the managed disk options in Azure, they're encrypted by default on the server side, so there's nothing you have to do to enable it. Networking in Azure comes in 2 different flavors, standard and accelerated. In standard networking, the entire network stack is abstracted and virtualized. This works very well, however, there are performance limitations. Standard networking tends to top out about 4 gigabits per second. Accelerated networking in Azure is based on single root I/O virtualization of the Mellanox adapter. This is basically the VM talking directly to the physical network card on the host hardware and has produced node-to-node network speeds of up to 20 gigabits per second. Keep in mind that not all VM types and operating systems support accelerated networking, and just like disk throughput, network throughput is based on VM type and VM size. So, what do you need to think about for networking in the Azure space? Again, stay close to home. Pick regions that are geographically close to your location. Yes, the backbones between regions are fast, but the more hops your packets make, the longer it's going to take. Azure offers 2 types of groupings for VMs, availability sets and availability zones. Availability zones offer good redundancy across multiple zones, but this increases the node-to-node network latency, so we recommend you avoid this. Availability sets, on the other hand, keep all your VMs grouped together within a single zone while making sure that no 2 VMs run on the same host hardware, which is important to reduce any downtime due to a host failure. Just like other clouds, UDP broadcast is not supported, so you'll have to use the point-to-point flag to ensure that spread works properly. And finally, a word about spread timeout. Microsoft implemented its update process as rolling updates in their environment. What this looks like from a VM running on top of hardware that's receiving an update can be thought of as the VM being paused. This becomes problematic when the pausing of the VM exceeds 8 seconds, as non-paused members of the cluster will think that the paused VM is down. Consider adjusting the spread timeout for clusters in Azure to 30 seconds to help avoid nodes from being dropped from your cluster during a maintenance event. If you're deploying a large cluster into Azure, use large cluster mode as it will scale much more effectively. And finally, pick VM types and operating systems that support accelerated networking. The difference in node-to-node and node-to-storage account speeds can be dramatic, and it's free to use. So with that, we've hit the end of our presentation and are about to open up Q&A. On behalf of Jeff and Shruti, myself, thank you for joining us, and let's start Q&A now.
Great job with the presentation, Chris and Shruti. We're going to get started with some questions that we've seen that have come in. Let me take a peek here. It looks like the friend, Shruti, I think this one's for you. Can we provision nodes with different hardware configuration for Eon subclusters?
Yes, you can provision nodes with different hardware configurations for Eon subcluster, but however, the nodes within the subcluster should have same hardware config. For secondary subcluster, you can't have a node with 8 CPU cores and another node with 16 CPU cores. That's how it has to be.
Got it. Okay. Well, thank you, Shruti, for that. It's helpful. Okay, we've got more coming in here. Chris, I think this one's over to you. You let me know. We'd like to utilize the new custom Vertica disk image in Azure with our own automation. How do I access it for deployment?
Okay, so that's a fairly easy question. Starting with version 11, we've moved both of our marketplace solutions over to this image that we're providing for Vertica, just like an AMI would in AWS. Within the next month or so, I think I'm going to do a blog post about it, talking about how to use it specifically. But for those customers that are looking to do it, right now, you can certainly go to one of the solutions from 11 when they publish, get all the way through it, and right before you hit the purchase, you can download the template. Within the template, you'll find the plan information and the image resource information that you can reference specifically to use our custom Vertica image for Azure.
Very helpful. All right, cool, Chris. Thank you. You guys both have all the answers. This is great. Got another one that popped in. Chris, I think it's for you. We already have a pure flash array in-house that is being used by other solutions. Can I use the storage array for my Eon on-prem solution, or does Vertica need its own array?
So the answer is a depending, right? So it really depends on how much that array is being used now. Again, it's back to that sense that when you're going on-prem, you're providing the support for the entire solution, not just the front end like you would in a cloud environment, but you also have to support the back end. So if you're going to use an existing array for your Vertica solution, you need to make sure that there's enough throughput into the array and that there's enough actual throughput in the array itself to handle the additional load that you're adding to it. Because understand that the slower performance coming from the array as you're doing things like writing into the array, or if you're writing directly to the array or querying directly from the array, will be affected by other loads that are happening there. Now, if the performance is fairly low at the existing array, sure, go ahead and do it. And there's no technical reason you can't. Just from a sizing standpoint, consider that and take a look at what that array is being used for prior to going out and doing something production-like in it. Do a POC there.
Got it. Good guidance. Okay, we had another one pop in here around AWS, and it's where can I test out spinning up a free cluster in the Amazon cloud? What's the maximum nodes allowed for free testing? Chris, I know you know this one.
Sure, I can talk about that. So the maximum nodes for testing fall into the CE license, which is 3 nodes,
right,
up to a terabyte of data. So you certainly can do that. From a Vertica standpoint, you will have to pay for the machines that you're using. So when you say free, I'm assuming you mean free Vertica as opposed to free AWS or any other cloud, because they will want to be paid.
Totally makes sense. Shruti, do you want to add anything else to that? Any more color around Amazon? Or did Chris take it?
No, it looks good.
Okay. Just want to make sure we had everything comprehensively addressed, which you guys have obviously done. Any other questions last minute, last chance, last call? Bring them on. You've got some of the brightest minds from the customer success team here. Otherwise, we will get ready to wrap. Okay, let's do that. Thank you to our audience for your great participation. If any questions come in while I'm covering the conclusion here, we'll make sure we answer those offline. And again, our engineers are in the developer lounge as well. So if you have any other questions beyond over the course of the 2.5 days, make sure to hit the developer lounge. You're going to be right with the engineers. They'll be able to address those questions. Now, please note that a replay of today's event and a PDF copy of the slides will be available on demand shortly. And of course, we invite you to share them with your colleagues. Again, thank you to our audience today. Don't forget to type the session code into the Analyze to Win section of the event navigation panel. Note that there will be a short message from our sponsors that I encourage you to stick around and catch. It's going to lead right into the sponsor showcase. Make sure you visit our sponsors. A great way to understand how Vertica fits into this growing ecosystem. But for now, this concludes this breakout session. Have a great day, and we hope you enjoy Vertica Unified 21.